guys, welcome back to GCSE Maths Attack. Today we're going to look at adding and subtracting fractions with different denominators. So let's begin. Okay, so over here we can see that there's a 4 and there's a 12, so the denominators are different. So we need to think of numbers in order for the denominators to be the same. Now I know that I can actually multiply the denominator by 3 in order for that to change into a 12. So whatever I do to the denominator, I must do to the numerator in order for this fraction to become an equivalent fraction. 3 times 3 is 9, 4 times 3 is 12, plus 1 over 12. 9 plus 1 is 10, and the denominator stays the same. The misconception is 12 plus 12 is 24, but be careful, the denominator always stays the same. Now if I look at 10 over 12, I know that this can be simplified more further. So you can divide the top by 2 and the bottom by 2. So 10 divided by 2 is 5, 12 divided by 2 is 6. Now I know that this is the simplest form because 5 and 6 I don't see in any other times table. Okay, so we got 3 over 5 minus 2 over 7. Now I could sit here writing down all of the 5 times tables. So I can write 5, 10, 15, 20, 35, 40, 45, 60. Okay, and I could sit here and write down the 7 times table. So 7, 14, 21, 28, and 35. Oh, hang on a minute. Both of the denominators can be 35. Now I can sit down here and work out the lowest common multiple, or just to save me some time in the exam, I can look at the denominators and say to myself, well, there's a 7 here and there's a 5 here, so I can multiply this by 7 and I can multiply this by 5, because if I do 5 times 7, that's the same as 7 times 5, and they'll both give me 35 and I don't have to think about it. So whatever I do to the denominators, I must do to the numerators. So this is times 5 and this is times 5. So 3 times 7 is 21, 5 times 7 is 35, 2 times 5 is 10, 7 times 5 is 35, 21 take away 10 is 11, and 35 remains the same because the denominators don't change. Now after I get to this stage in the exam or any question that I'm given, I need to ask myself, can I simplify this fraction? Is there any times table that I can put in and divide it by to cancel it down? And I can see there's no other times table. I can't divide both of these by 2 because it will give me a remainder. I can't divide both of these by 5 because 11 is not going to divide by 5 and it will leave me a remainder. Okay, so these are the questions that you need to ask yourself. Now in the exam, if it doesn't ask simplify this, but usually they do ask, but if it doesn't, you can just leave your answer in the unsimplified format. So you can leave it like that. However, if it asks you to simplify it, you need to get to this stage over here. I've got some questions over here. I would like you to pause the video and have a go at this question. So I'm assuming you paused the video and you've had a go at these questions. Now I can see that the denominator has 6 and 2. What I can do is I can use common sense and say to myself, well, I've got 6 here and I've got 2 here. I can times this by 3 and then the top by 3 as well. So that will leave me 5 over 6 minus 3 over 6. Now I can do 5 take away 3, which is 2, and that will be 2 over 6. If I was going to simplify this, I know both of them are in the 2 times table, so I'm going to divide both of them by 2. 2 divided by 2 is 1, 6 divided by 2 is 3, so your answer is 1/3. Okay, so next, right, so I got 4 and 5. Can't really think of any numbers that I can use, and I don't want to really use my brains that much, so what I'm going to do is I'm going to times this by 5 and times this by 4. Now some of us might be quick and realize that actually I can just use 20. I can make the denominators 20, but if you're slow, just swap them around. Right, so whatever you do to the bottom, you must do to the top. So times by 4 times by 4. So 3 times 5 is 15, 4 times 5 is 20, 2 times 4 is 8, 5 times 4 is 20. Okay, so 15 take away 8 is 7, so your answer is 7 over 20. Can I simplify this? No, I can't. So I can't think of any number to divide this by to simplify it. Okay, next. Okay, so I've got a 9 here, I've got a 4 here. Don't really want to use my brain, so I'm going to times this by 9. And I'm going to times this by 4. So 3 times 9, what is that? That's 27. 4 times 9, what is that? 36. 2 times 4, 8. 9 times 4, 36. Right, 27 plus 8. So if I was going to plus 10, that would give me 37. And if I subtract 2, that's going to give me 35. So it'll be 35 over 36. Can I simplify that? No, I can't. So I'll leave it like that. So I'm going to times this by 6, and I'm going to times this by 5, times this by 6, and then times this by 5. So 5 times 6 is 30, 3 times 6 is 18, that is 10, and that is 30. So 18 plus 10 is 28 over 30. Can I simplify that? Yes, I can. So I'm going to divide both of them by 2. You are left with 14 over 15, and that's simplified. Now, if you got those questions correct, well done. If you never, pause the video and have a go again. Okay, so we're getting to more wordy questions over here. So let's read. In a bag, there are red, green, and purple counters. 3/8 of the counters are red. 1/6 of the counters are green. What fractions of the counters are purple? Now, in order to answer this question, what you have to do is you have to make sure you create equivalent fractions. And it comes back to the idea of a bar model. So if you haven't watched my previous video, we talk about the bar model and how we're supposed to split this. Now, if I have fractions with different denominators, I need to make sure the new denominators are the same. So I've got 3/8 which are red, and I have 1/6 which is green. Okay, so what I'm going to do is times this by 6, and I'm going to times this by 8. So I know that it's going to be out of 48. So 3 times 6 is 18. 1 times 8 is 8. So I can do 18 over 48 plus 8 over 48. So I know my whole bar is out of 48. So if I add them up, so I've got 18 plus 8. 8 and 8 is 16. Carry 1, that's 26. Then I can do 48 subtract 26, because that will tell me how much I need to split this into to give me 48 in total. So I will do 48 subtract 26. 8 take away 6 is 2. 4 take away 2 is 2. So you've got 22 over 48, which is purple. Now, because the question didn't say simplify it, you can leave your answer like that. However, if it did say give your answer in the simplest form, you would have to divide both of them by 2 and then see what you get. So divide by 2, divided by 2, that gives me 11, and that gives me 24. Okay guys, so we're told to add 1 2/5 plus 2 1/2. Now how am I going to add this up? There's several techniques of doing this. Some people do it like this. So they add 1 whole plus 2. So 1 plus 2 is 3. And they got 2 over 5th plus 1/2. So they times that by 2, times that by 2, times that by 5, times that by 5, which gives you 4 out of 10 plus 5 over 10. So 4 plus 5 is 9, 9 out of 10. So that will be 3 wholes and 9 out of 10. Or another method that you can use is you can change both of them to improper fractions. Now, in order to change them to improper fractions, you need to multiply 5 by 1 and then add it by 2. So 5 times 1, which is 5. So the denominator stays the same. 2 times 2, which is 2. So 5 times 1 is 5. Add 2, which is 7. And 2 times 2, which is 4. 4 plus 1, which is 5. And then what you can do from here, you can add them together. So what is, oh, before you can even add them, you need to make sure the denominators are the same. So you're going to times this by 5, times this by 5, times this by 2, times this by 2, which gives me 14 out of 10 plus 25 over 10. So if you're going to do 14 and you're going to add it by 25, 4 plus 5 is 9, and that will give me 39 over 10. And if I want to change that back into a mixed fraction, while the 10 stays the same, I say to myself, how much 10 goes into 39? That's 3, so 3 times 10, which is 30. My remainder goes at the top, which is the 9. So that is another technique that you can use. Okay, so what I did was basically, for the first technique, so let me just go over it one more time. All I did was add 1 plus 2, which gave me 3. Then I made the denominators the same, because in order to add or subtract, you need to make sure the denominator is the same. So I did 10, I made the denominators a 10, so I did 4 plus 5, which is 9, which gave me 9 out of 10, and I just attached it there to the 3. Or what you can do is you can change both of them to improper fractions, which I did, and then I made the denominators the same, which I did at this stage over here. And then I added 14 plus 25, which gave me 39, so it gave me 39 out of 10. I said to myself how much 10 goes into 39, and that was 3 wholes. 3 times 10, which is 30, and then I need to reach my goal of 39, so I add the 9 at the top. Okay, let's begin the next question. So, whichever technique that you like, you must follow through. Now, I'm going to do this technique again. So, 4 take away 3 gives me 1. I got a third minus 4 over 9. I'm going to times this by 3, and I'm going to times this by 3. 3 times 1 is 3. 3 times 3 is 9. Subtract 4 over 9. So, I got 3 take away 4, which gives me minus 1 over 9. So, I'm going to attach that over here. So technically what I'm saying is 1 minus 1 over 9. But how's that possible? Well, 1 whole can be written down as 1 over 1. So you can times that by 9, times that by 9. 9 times 1 is 9. 9 times 9 is 9 minus 1 over 9. So 9 take away 1 is 8. 8 over 9 is your answer. That's one way you can do this question. The other way you can do it is by changing them to improper fractions. So I'm going to go through that technique in a second. So let me just quickly erase this. Okay, so the next way is to change them to improper fractions. So remember, I times the bottom and I add it on. I times these two together and I'll add it on to anything that's in the numerator. So 4 times 3, well, 3 stays the same here and the 9 stays the same here. 4 times 3 is 12. 12 plus 1 is 13. 3 times 9 is 27, 27 plus 4, which is 31. Now I'm going to times this by 3 and I'm going to times this by 3. So 13 times 3, so 3 times 3 is 9, 3 times 1 is 3. So you got 39 over 3, subtract 31, 9. 31 over 9, 39 take away 31, which is 8, and your answer is 8 over 9. Okay guys, so here's some questions to have a go. Pause the video and have a go at these questions. Right guys, let's go through the solutions, and whichever technique that you liked, you can stick to that. I'm going to do the one that I like the most, and that's changing them to improper fractions. If you don't like that, that's fine. So the numerator stays the same, and what I'm going to do is I'm going to do 5 times 2, and then I'm going to add it. I'm going to do 6 times 4, and then I'm going to add it. So 5 times 2 is 10, 10 plus 1 is 11, 6 times 4 is 24, 24 plus 3 is 27. Okay, so in order for me to add these, the numerators need to be the same. So I'm going to times this by 2, and I'm going to times this by 2, which gives me 22 over 4 plus 27 over 4. Now that the denominators are the same, I'm going to add them up. So 22 plus 27, so let's write that down, 22 plus 27 add them. 2 plus 7 is 9, 2 add 2 is 4, 49 over 4. Now, I can change that back into mixed fractions. So how much 4 goes into 49? That is 12. The 4 remains the same. 12 times 4 is 48, and I have a remainder of 1. So that will be my answer. Okay, so let's quickly go through the next one over here. So I'll just use a different color pen. I'm going to keep the 5 the same. I'm going to keep the 2 the same. Okay, 8 times 5, which is 40. 40 plus 4, which is 44. 1 times 2 is 2. 2 plus 3, which is 5. I'm going to times this by 5. I'm going to times this by 2, just in order for the denominators to be the same. So they're both going to be 10, and they're both going to be 10. 5 times 5 is 25. 44 times 2 is going to be 88. I'm going to do 88 plus 25, which gives me 113 over 20. I can change that to mixed fractions. How much 20 goes into 113? That's 5. The 20 stays the same. 5 times 20 is 100, and then you have 13 remainder. So that would have been your answer, and that would have been your answer as well. If the exam says change to mixed fraction, that is where I would leave my answer. Okay, right, next. So let's get a brown color out. Right, we're going to change this. So this will become 2. This will become 3. Subtract, subtract. 2 times 2 is 4. 4 plus 1 is 5. 1 times 3 is 3. 3 plus 1 is 4. I'm going to times this by 3, times this by 3, times this by 2, times this by 2. 5 times 3, which is 15, over 6 minus 6, and then 8. And now I can subtract them. 15 take away 8, which is 7 out of 6. I can change it to mixed fraction if I want to, and that would be 6. 1 times 6 is 6, and 1. So my answer will be 1 whole over 1 whole 1/6. Okay guys, so here's a wordy question for you. Please do pause the video and have a go at this question over here. Okay guys, let's read the question. So it says, Sam is training for a race. He runs 3 days in 1 week. Sam runs 1.5 miles on Monday. Then runs 1 2/3. So I'm going to highlight that. 1 2/3 on Thursday. Finally, he runs 2 1/5 on Sunday. Work out how far Sam has run in total. So basically what we're doing is we're just going to add them up. So you've got 1 1/2 plus 1 2/3 plus 2 1/5. So what I'm going to do is I'm going to add these whole numbers. So 1 plus 1 is 2, 2 plus 2 is 4, then I have a half plus 2/3 plus 1/5, and I have to ask myself that question of what will the denominators be. So all the denominators can go into 30. So I can make all the denominators change into 30. So I'm going to times this by 15, times this by 15, times this one by, I don't know, 10, times this by 10, times this one by 6, times this by 6. So that will be 15, that will be 20, that will be 6. So you're going to do 15 plus 20 plus 6. 5 plus 0 is 5, 5 plus 6 is 11, carry 1, and that's 41. So your answer will be 41 over 30. So you've got 30, 41 into 30 is 1, and that will give me 11. So you got 1 whole 11 out of 30. So well done if you got that question correct. Okay guys, so here's a final question. You got 2 pi over 9 plus pi over 4. Have a go at this question and see how you'd answer this question. Okay, so I'm assuming you paused the video and you've had a go. Now, in order for me to even add these, I need to make sure that the denominators are the same. So I'm going to multiply this by 4 and I'm going to multiply this by 9. Whatever I do to the denominators, I must do to the numerators. So I'm going to multiply this by 4. Because I multiplied the denominators by 9, I must do that to the top. So 2 times 4 is 8, and it will be 8 pi. 9 times 4 is 36. Pi times 9 is 9 pi. And 4 times 9 is 36. Right, this is how I'm going to do my adding. 9 and 9 is 18. 18 take away 1 is 17. So it will be 17 pi over 36. Now, if you got that question correct, well done. If you never paused the video, see where you went wrong. Most of the students probably just added them. But remember, this, just because there's a pi there, the laws still apply. If the denominators are the same and it's a fraction, you need to make sure the denominators are equal in order to add and subtract. If you got this far to my video and really enjoyed it, please do leave a comment and please do subscribe to my channel.